Hello there and welcome everybody. I think that there are some issues here with the camera. I think it moved somehow. Let's see. Okay, let me put myself here. Yeah. All right, let me go to the live stream to check that everything is correct. So let me switch right now to the computer camera. Okay, yeah, I'm gonna have to fix this. Let me see. All right. So let me know if the sound is fine. I see that the image is not very well, but I'm going to try to fix that right now. Give me just 1 second. Right, hello there. I can see Gabriel Garcia, Nancy, Rick Hernandez. Hello everybody. Yeah, so sound is perfect, says Thomas. Perfect, okay. Hello also Dave. Hello everybody. So yeah, welcome to this open class. We are already in open class number 154, which are quite a bit of them. And today we are going to be introducing Docker. Yeah, we are going to start from the very beginning, so something very basic, but we are going to start using some basic commands and basic images, and we will get a little introduction into Docker. All right. Hello, everybody. I can see here more people coming. Eric, Nick, Narcisse, Song. Welcome everybody. All right, so let's get already started. So, as always, I don't know if you have been in previous open classes, maybe this is your first. In any case, the procedure to follow is always the same. So, the first thing that you need to do is to get the rosject related to this open class. Yeah, and this can be done very easily by just clicking here in this light blue button that you have here right above the chat. So I'm going to do this myself right now here. Let me click it. And then this is going to create a copy of the rosject into your workspace, okay? I am getting this message. So it looks like we have a lot of people in our system right now. So it's going to take a bit longer than usual to load my rosject. Okay, never mind. Let me leave this here loading, and I'm going to go back to the live stream here. So that I can Unfortunately, the rosject doesn't start. Still processing, says Thomas. Okay. Do you mean with processing? Do you mean like me? Like this, that it's loading, basically. Yeah. Hello from Luxembourg, says Gabriel. Yes. Yes, now it has finished. Okay, lucky you, Thomas. It took max 5 minutes to load the rosject, yeah. Mine, I think it's going to take a little bit longer. Yeah, so when you get this message, it means that a new computer is being launched from zero, because all the rest are already fully at the full capacity. So it's starting a new computer, and then it takes a bit longer. But hopefully it's only me that I am getting assigned to a new computer, so I'm going to have to wait a little bit longer. But no problem at all. Alexei says, I guess because everyone clicked button at the same time. Amna says that he has, or she, I don't know, by the picture, it looks like she, has the same message as me. Okay. Yeah, so, okay. Well, mine is already starting to load. So once you get the rosject loaded, you are going to. So first of all, two things are going to happen. First of all, you are going to get a copy of the project of the rosject into your rosjects area. Okay, so if you log in into your account and you go here to my rosjects area, you are going to have a copy of this rosject, and you are going to have this copy forever. Okay, so you are going to be able to relaunch it tomorrow, next week, next month, whenever you want. Okay, in case that you want to review it later, you want to do your own test. There are many things that you can test here. So yeah, you can reopen it and review it whenever you want. So you are going to have this copy in your account forever. This is the first thing. Second thing, as you can see, is that it's going to redirect you automatically, like I am here, to the rosject page. Yeah. Then you are going to have here at the right side the streaming panel with the live stream and the chat. So I'm going to leave this open during the class so that I can see your messages and your buttons and your messages, in case that you have any questions, problems, etc. And then when my computer finishes loading, I'm going to be able to see here the main rosject page with the notebook and everything. That for the ones that it has already loaded, you are going to already see it. Okay, then just a couple of things, all right? Meanwhile, my rosject is loading, I'm going to comment about a couple of things. First one is, so in order to follow this class, okay, you should have a minimum knowledge of Linux, okay? We're going to be running some Linux commands, we are going to be working with shells, etc. Yeah, so it would be good that you have a minimum knowledge of Linux, which you can get, for instance, in our free course, Linux for Robotics, okay? So here it's going to be teached everything related to Linux basics. It's a very, very interesting course to get introduced into Linux operating system, and it's completely free. So yeah, give it a look. Give it a look if you want to get this foundation on Linux systems. And second one is that we are going to be doing an introduction to Docker, and we are doing this open class because this week we have published the new course Docker Basics for Robotics. Okay, so today we are going to get a very little brief introduction to Docker. But here in this course, you are going to find many more things, like creating your own images, working with containers, volumes, Docker Compose to launch multiple containers at the same time, Docker with ROS, etc. Okay, so this course has been published, has been released this week. So yeah, in case that you are interested on it, give it a look. Okay. All right, and meanwhile I was explaining all this, my rosject has been loaded. Yeah, so here you can see that I have automatically loaded the notebook right here. It's the notebook for today's class, number 154, Docker Basics for Robotics. Okay, so all of you should be in the same page as I am right now. Yeah, so with the rosject loaded and the notebook also here opened. Yeah. Have you reached this page? Is your rosject still loading? Yes, still loading. Says Fatima. Okay. Yeah, don't worry, Fatima. If it's still loading, it's going to finish loading in very soon. Notebook just opened. Perfect. Okay. Then, yeah. So I was talking about this requirement about Linux Basics for Robotics. Also, we are going to be running some ROS commands, very basic ROS commands. Okay, but yeah, not so important for this. Then Docker. So how many of you have experience with Docker? Have heard about Docker? How would you explain what Docker is? Or what it is for? Only heard of, says Alexette, but never used it. I did basic things, says Dave. A little bit of experience, says Chelsea. Containerized applications, very well. I used Influx once for creating a dashboard. okay, is used to run a temporary version of an operating system. Okay, a container for running a program. It solves the "it works on my machine" problem. Yeah, that's a good definition, Dave. And no experience is narcissist. I've been using Docker for ROS and AI for years. It's a system that allows creating an encapsulated environment with its own packages and file system, says Elio. Very well. It's like a virtual box. Okay, yeah, makes kind of sense. I would say Docker is a way to replicate applications in an isolated, repeatable environment without all the overhead of a virtual machine. Yeah, I like this definition also. So it looks like more or less all of you know what is Docker, at least in general terms, and you have an idea of what is Docker useful for. So yeah, Docker basically is used to containerize applications. Yeah, so you can create an environment, an isolated environment, with your specific configuration. Configuration meaning you can configure what operating system you want. You can configure, for instance, in this case, a specific version of ROS, and a specific version of Gazebo, etc. Okay, so you can define all these into a file that you can execute anywhere. Yeah. So it's isolated from the host operating system. Yeah, so you can, this allows you to replicate. I have read it somewhere there. Yeah, repeatable, says Chelsea here. An isolated repeatable environment. So I can share the image with anybody, and it can be very easily replicated and executed in any other environment. Yeah, so you don't have to worry about setting your local computer with the dependencies and everything. All this goes doesn't matter anymore. Yeah, this goes in the line that Dave was saying, that it solves the "it works on my machine" problem. Yeah, so if you have, as long as you have Docker installed, you can run any Docker image and it's going to work, no matter the environment, the operating system you are in. Yeah. Okay. Then here you have some explanations, an analogy to what is Docker. But let's start. In this case, we're going to start by installing it. Okay. So by default, we don't have Docker here in this project, so we are going to need to install it. Then we're going to start from there. So we are going to start by opening a new shell. Okay. Then how I have done this? Let me repeat it. Very easy. You come here to the down bar where you have different icons, and then you can select the first one, which is web shell. Just by clicking here, this is going to open a new web shell. Okay. Let's make this bigger. And then this is a regular Linux shell. Okay. So here we are on an Ubuntu system, specifically. Yeah, I don't have here the exact information, but I think this is an Ubuntu 20 system, okay? And this is a regular Linux shell. So here you can type regular Linux commands, okay? Nothing special. Then we are going to start by installing Docker, yeah? So for this, you can use these commands, these two commands. And what I suggest is that you can type them here directly in the shell, or you can copy and paste them here from the notebook. Yeah, I'm going to do this. So you can select here the specific command, copy it, for instance, with Control-C if you want the shortcut, or you can also copy it like this. And then you come to the shell here. Let me clear this. And you paste it. And you can execute it, okay? This is going to save you time, and it's going to make sure that you don't do any typos while writing the command, etc. Yeah. Then we do the update first of all, and now we are going to install Docker and Docker Compose. So let me select the command from here and paste it. There we go. Okay. Now here it's going to ask you for confirmation, as you can see, because it's going to install many packages. Then when you have to install multiple packages, it asks you for your permission. Then you can hit enter here, and this is going to start installing the packages. My shell doesn't load, says Dave. Shreya says my terminal is disconnected. Okay. What do you mean, Dave, by it doesn't load? Disconnected, if it's disconnected, what I would suggest is maybe it's disconnected. Click here to connect. Okay, and what happens if you click there to reconnect? Does it reconnect or not? Nothing. Okay, then let's try one thing. Close here, okay? Come here to the terminal shell and close it and try opening a new one. Again from zero. Come here. Okay, same also Nancy. That's pretty strange, let me say. So even closing and reopening. Okay. Let me see if I can get some assistance. Alexei says all works for me. I had the issue, changed browser from Edge to Chrome, and now it works. Okay. Yeah, so I would recommend that you use either Chrome or Firefox. So our application, the constructor application, works better in Chrome and Firefox. So maybe it could be related to that, and all of you are using another browser which is not properly supported. Dave says Firefox. Yeah, in Firefox it should work okay. I am working in Chrome, neither Opera. On Firefox, it's not working. Okay. Really strange. Okay, can we try one thing for the ones which is not working? Can you try clicking here? This is going to move this to a new app, to a new tab. Sorry. See, it opens. It moves the terminal to a new tab here. Can you test if that works for you? It's very strange, but that for some people is working and for others don't. All white with the yellow question mark at the bottom. Blank page. Wow. Okay, I have already asked for my colleagues to have a look. Let's see if we can figure out if something is going on there on the servers and your computers have not been properly initialized. Waiting for cache log. It is held my process. Okay, that is interesting. Let me get that message. Let me send here. Meanwhile, yeah, I'm sorry for that. I don't know have no idea what's going on. Okay, so my colleagues are telling me that it might be because the computer is not fully ready yet. So the ones that got the ones that you are getting this error, the ones that you are getting this error that you cannot properly load the shell, did you get the same message as I did, that the computer was initializing and it would take 10 minutes and so on? Because my colleague is telling me that maybe it is because the computer you are in is not 100% ready yet and doesn't have the shell ready. Now it works. Okay, so it might be because of that. Yeah. So the shell was not initialized yet in the computers. Okay. Then for the rest, did it got solved? Can you normally start a web shell? Okay, let's do one thing. Let's wait a couple of minutes to see if it gets fixed. Yeah, Elio says not yet. Also Fatime, not yet. Okay. So yeah, I already have them installed, so it's not going to install anything. Let me just run these commands. Meanwhile, we wait. So in theory, yeah, so it's already installed. I don't need to install it again. And then just to complete the Docker setup for the ones that you have it, you have to start the Docker service. You can do this with this command, sudo service docker start. And after you start the service, now you are going to already be able to start using Docker commands. So for instance, you have Docker PS with sudo. Yeah, so right now we don't have any container running, so you don't have anything here. Or we can list the images also with sudo docker images. Okay? Not cocker, but docker, yeah. Sudo docker images. Okay? Then if you want to don't have to use sudo in order to run Docker commands, you can also execute this. Yeah. Otherwise, you are going to have to run sudo whenever you want to use the Docker command line tools. Yeah. But if you run these two commands, yeah, let me do it here and add the new group. Yeah. So all these are Linux commands. So now you are going to be able to run Docker commands without sudo. All right? We can see your screen. Yeah, you are right. Sorry for that. Now you are able, right? Yeah. Okay. Yeah, so I was just installing this. Okay. Then once you have to start the Docker service with this command, sudo service docker start. After you install the packages, okay, you start the service, and then after you start the service, you are already able to run Docker commands, but you have to use sudo. Okay, then if you don't want to use sudo, you can execute these two commands down here. As you can see, I have done this. Yeah, so first you have to use sudo, but after running these two commands here, you can use the Docker without having to use sudo. Okay? Then, share the screen, yes, okay. So, can you already access your shells, your terminals? The ones that were not able yet? Do you have the shells working now? Let me see who it was. Helio had some problems. It is working for me, says Gabriel. Nope. Fateme, no. Shreya Nair says no. Okay. Not yet. Okay. So I don't know, working for me. I don't know what to do. I don't know if we should continue. Yeah, maybe we can continue with the class, and for the ones that the shell is not working, maybe you can retry it later. Maybe in some minutes it's going to work. It's strange. It should be working already. I have to say that. But what do you think if we keep going with the class? It's something very basic, so you are going to be able to replicate it later without any problem. Yeah, we are not going to do any complicated stuff. It's all very basic. And you are going to have this rosject forever, so you can reproduce it whenever you want. Okay, Fateme says no problem. Eli also. Okay, then let's keep going. Then okay, yeah. So you can be seeing to what I am doing. Keep trying. Okay, to open the shell, because eventually I think that it's going to work. But meanwhile, while it's not working, just you can see to what I'm going to be doing and try to understand. Okay, and then later you can replicate it and reproduce it yourselves. So yeah. So in the first step, we have just installed Docker. Okay, Docker setup. We didn't have Docker installed here, so the first thing that we have to do is to install Docker, install the Docker packages, start the service, and we can already start using Docker. Okay. Then the first thing that we are going to do is to pull an image. Okay. So Docker is based on images. Yeah. You can think of a Docker image as a box which contains the definition of the environment or of the application that you want to execute. Okay? This application that you want to execute is defined in a Docker image. Okay? It is defined the operating system that it uses, the ROS version that it uses, etc. Okay? Then if you want to run your application, run an application in Docker, you have to have a Docker image. Yeah? Then you can create your Docker image, which is something that we are not going to cover in this class. This is covered in the course. And you can also download a Docker image which has already been created, which is already available. This is what we are going to do right now. Okay? And we are going to do this with the docker pull command. Okay? And in this case, we are going to download this Foxy ROS-based Docker image. Okay, so let me copy this command here from the notebook, and I'm going to run it here. And you are going to see that this is going to start downloading some things. Okay. And this image, we will see later, okay, where this image comes from. But basically, within this image, we have ROS2 Foxy available. So if we execute this image, we are going to be able to start using ROS2 Foxy from the scratch without having to do anything else other than downloading the image and running it. Okay? Then this has already finished, downloaded newer image for Foxy ROS-based. So I already have my image here. For instance, if I run Docker images, I can see that I already have this image in my system. Okay? And we can do the same, for instance, for a noetic image, okay? So what if we want to work in ROS1? We don't want to work in ROS2, but we want ROS1, okay? So we download a ROS1 image. So let's do this with this other command that we have down here. And now we are going to pull a ROS noetic image. Here I can see George, which says permission denied, solved by running the permission related commands. Yeah. So here, as you can see, we are running Docker without sudo. Okay. Then you have to be able to do this, you have to run these commands. Okay. Otherwise, you are not going to be able to run Docker unless you use sudo. Okay. So make sure that you execute these two commands in the shell. Okay. So that you don't get permission issues. All right. And okay, so we have downloaded a ROS noetic image, Docker image, a ROS Foxy Docker image, but of course you can download as many as you want. Yeah. For instance, here you can download an image that we have created. We, as the construct, we have created this Docker image. ROS2 examples, and you can also download it. So let's also download this one. Yeah. So not only. What does this mean? This means that you developers, anybody, you can create your own images, okay, and make them available for anybody to use them. Yeah. So this is one of the powers of Docker, that you can create an image, and anybody from anywhere can download this image and start using it just by downloading your image. Yeah, with a simple Docker pull command, you can download any image and get into it and start using it. Yeah. So this is a very strong point, a very powerful feature that Docker provides. There we go. Now, so we can run the Docker images command again, and we would expect, let me put this a little bit bigger to see it better. Yeah, and we can see here the three images that we have downloaded. We have downloaded the Foxy ROS-based, noetic ROS core, and the examples from the construct sim, this image that we have created. Okay, so. Yeah, so now we have our images in our system. So now what? Okay, so now if we want to actually get into these images, start using them, we have to run a Docker container, what is known as a Docker container. Yeah? So this is what we are going to do next. Well, before that, we have, so here you have some more examples, just to show that you can pull any kind of image. Yeah. So in this case, we have downloaded the ROS images. We have downloaded also an image which is ours, which is from the construct. But you can download, for instance, also images related to Ubuntu, different versions of Ubuntu, different versions of ROS, etc. There are many images. We will see these at the end when we have a look at the Docker Hub. Okay, but you have here a demonstration that you can try these commands if you want. I'm going to skip them, okay, for now, because it's basically more than what we have been doing so far. Okay, what I do want to show is the structure. Okay, so as you can see from the Docker images command, we have the repository and we have the tag. Okay, so if we specify this command, Docker pull, let me put another one, this one for instance, Docker pull ROS noetic ROS core. Okay, so as you can see, this noetic ROS core is the tag. Yeah, and this ROS is the repository. Okay, so one repository can contain many tags. Okay. Then For instance, here that we are specifying this Ubuntu 2004. What does this mean? This means that we want to pull an image from the Ubuntu repository with the tag 2004. Yeah? And this is very common. This is very common because, for instance, for the Ubuntu repository, you are going to have many different images with different tags. You can download the 2004, 2010, and many others. And the same with ROS. Yeah, so under the ROS repository, you are going to find many different images with different tags. Yeah, some of them for Noetic, for ROS melodic, even for ROS2 Foxy, ROS2 humble, and even with the same distribution, there are many different tags. Yeah. Okay. Then, yeah, so let's start using one of these images. In this case, we are going to create a container of the construct sim image. Yeah, these ROS2 examples that we have also downloaded. Then, in order to get into it, we have this command, docker run it name my container. Yeah, so this name is the name that you want to give to the container. In this case, it's my container. This is the name of the image. And this bash, it means that we are going to access the bash of the image, okay? The bash terminal of the image. So, yeah, IT means that we are going to run an interactive terminal. Okay? We are going to access an interactive terminal. Yeah? And what is an interactive terminal? It's this. Let me run the command here. Yeah. Once you run it, you are going to be here, okay? So as you can see, I'm right now in a terminal. Yeah, I can run also commands. Yeah, so I'm in a terminal. So right now I'm in a terminal inside the container of this Docker image. Okay? Yeah? Are you following? Does this make sense? Yes? Okay. So, yeah, so we have Docker images. Okay, a Docker image is a file which contains the definition of your application, let's say. And then if you want to actually execute this application, which is defined in a Docker image, you have to run a Docker container, okay? So this is what we have done with this command. We have run a Docker container, and we have accessed an interactive terminal inside my Docker container. Yeah? So right now I am inside my Docker container with a terminal. Okay? Then here I can start running, in this case, ROS2 commands. Yeah? So, for instance, we can here come and start already sourcing opt ROS Foxy setup bash. There we go. And you can run already a ROS2 command. In this case here we are running a minimal publisher from the ROS2 examples, okay? And if we execute this, you are going to start using ROS. So right now, I am already using ROS2. Okay? Then we are going to do some more examples later, but let's keep advancing a little bit. Then to see some concepts here. Then while inside the container, okay, while we are inside the container, we are going to create a ROS2 workspace. All right. So here, let's start with this command. We are going to create all these folders. Okay. See, so we have created the directory first home user, then home user ROS2 tutorial workspace, and finally SRC folder. Okay, so now we can get inside our new folder here, which is ROS2 tutorial workspace, and we can here compile. This is going to establish this folder as a ROS2 workspace, as a Qualcomm workspace. Okay, because I have compiled it here with Qualcomm build. So this generates all the build, install, and log folders. So right now, this is a ROS2 workspace that I have just created inside my container. Yeah? Yeah, so we can run this command, ls home user, here inside the container. And what are we going to have here? We have ROS2 tutorial workspace. Yeah? So inside our container, inside the path home user, we can also come here with cd home user. Inside here, inside home user, we have this ROS tutorial workspace, which happens to be a ROS2 workspace that we have just created. Okay? Then what happens if I open here another terminal? Okay? So this is a terminal, and here, if you click on the add button, this is going to create a new shell here at the side. Okay? Okay? So let me, I'm going to rename these to shell 1 and these to shell 2. Okay? You can rename them to whatever you want, or you can not rename them. Okay? I'm just doing this for clarity. Yeah? So here in my shell 1, I am inside the Docker container, and I can see that inside home user, I have my ROS2 tutorial workspace, right? So what happens if I come here inside home user also and run the ls command? That it has nothing to do, right? The output is completely different. Yeah, so here if you run this command ls home user, you get as output this ROS tutorial workspace. While if I run the same command here in this shell number 2, I get a completely different output, and I don't have at all this ROS tutorial workspace. So why is this? Can somebody tell me why I'm getting different outputs in the commands? Looks like SSH into other machine can configure whatever we want, is it? One shell is inside the container, the other not. It is isolated, right? Very well, very well. One is inside the Docker and the other not. Very well, okay, very well. So I see that you get the idea. Yeah, so here we are inside the Docker container. Yeah? And like somebody said, this is a completely isolated system. Yeah? Here, in shell number 2, we are in our local machine, in our local computer, let's say. Yeah, which in this case is the computer of the rosject. So here we are in our local computer. And in shell number 1, we are inside the Docker container, which is a completely isolated system from our local computer. Okay? So, very well. This is an important concept, yeah? To understand that these containers are isolated systems. Okay? Very well. Very well, very well. So let's keep advancing. Then, in order to list the containers, we can run the docker ps command, okay? So remember, sorry. So let's come back here. Let's come docker ps. Okay, yeah, so here, this is a new shell. So I'm getting this permission error, okay? So if I want to use Docker without sudo in this second shell, I have to run this command, okay? This, sorry, this new group Docker, I need to run it here. For every new shell that you execute, you need to run it, okay? Then, yeah, so we have seen previously the Docker images command, which shows us the image that we have downloaded into our local computer in this case. Yeah. Now we have this docker ps, which lists the containers that are running, yeah? So in my system right now, I have 3 Docker images, but I am running only one container, yeah? This container is, of course, this one, the one that I have run here, and I am inside in shell number 1, yeah? Remember that I did run this container with the docker run command, okay? So I have one container, which is named my container, running right now, yeah? So you can see the available images with Docker images, and you can see the running containers with Docker PS. Yes, Dave, yes. You need to run it for each new shell, this new group Docker, or you can add it to the bashrc file. If you know what you are doing, okay, you can add it to the bash src file. This one, okay? But these are Linux related things, so I'm not going to get into that. Yeah, okay, so where are we? Yeah, let me go back here. Running a Docker container, okay, so we have already done all this. We have seen that it's an isolated system. Okay, so now, what if we want, what if we want to get outside the container? You can run Control D, okay? So you can come here and run Control D here, right? Then you are going to exit the container, okay? So now, if you run here Docker PS, the container is no longer there. All right, Control D to exit the container. Okay, now I want to execute it again. Let's say that I want to execute it again. So I'm going to run the same command again because I want to execute it again, okay? It doesn't work. So here it says, error response from daemon conflict. The container name, my container, is already in use by container whatever. You have to remove or rename that container to be able to reuse that name. So what is going on here? Sorry, but it is possible to pay 1 month course from Russia? Yes. You can subscribe from anywhere in the world. Moved on. So our academy, you can subscribe for 1 month only if you want, and from anywhere in the world. So yes, it's possible. All right. So what is going on here? Okay. What is happening is that we have exited the Docker container, but in fact the container is still running. So it's still running in the background. We cannot see it here in Docker PS. But if we run a Docker PS -a, we can still see it here. Okay, the minus, if we do Docker PS help, you're going to see that the -a shows all the containers. Default shows just running. Okay. If you are moved on, if you have problems, you can click here in this Get Help button. This yellow. Oh, I think that you cannot see it right now. Yeah, right here. Yeah, because I'm right there in the middle, right? What happens if I move a little bit? Yeah, it's down there. Yeah. So right below the chat, you have this yellow interrogation mark that you can click, and this is going to take you to the forum. Okay. If you click here, it's going to take you to a forum. So here you can make any questions or problems that you are having. All right. So yeah, then there is a difference. Okay. So the default command shows just running. Yeah, Docker PS shows running. Then our my container is not running because we have exited it, but it's still there in the background. Okay, so in order to see these background containers, you can run this docker ps -a, and you're going to see it here. Okay, then since you still have the container here, you are not able to run another container with the same my container name. Yeah, so here you have two options. Option number one is to rename your container to whatever, let's say second container, okay? And then you can run it without any problem, okay? And now, if you run docker ps, you are going to see this second container running, yeah? And now, if you exit this second container also with Control D, there you go. It's going to be removed from docker ps, but you are going to see it also here in docker ps -a, okay? Even if it's not running, does it take memory or resources? Yes, it does. It does, Gabriel. Yes. So how do we remove them from here? Okay, that's a very good question. Then docker ps -a, docker's run it. Here we are running the second container. Basic docker commands. Okay, so you can run here. We can run here the docker help command. And here you are going to you can see a list of all the possibilities of the docker commands. Okay, there are many of them. Here you have management commands, regular commands. Here is where you have the run command, for instance. And we are not going to go over all of them. Okay, you can do your own tests whenever you want. But in this case, the one that we want is RM, remove one or more containers. Okay, so if you want to completely remove them from the system, you have to use the rm command. Yeah. So here, let me run again the docker ps-a. Then here, if you want to remove them, you can use the docker rm command, and then you specify the name of the container. Okay. In this case, the names are. Let me make this a little bit bigger so that. Oops, sorry. So that we can see the command properly. Yeah, so docker PSA, yeah, we have the image name, the timestamp when it was created, the status, and the name of the container, yeah? So docker rm second container, for instance. Okay, so now if I run PSA again, I don't have it anymore. And I can also remove, of course, the my container. Docker rm my container. Okay, and now I don't have them anymore here. Even. Not memory, but the storage, right? Yeah, exactly. Yeah. Yes, Dave. I'm not sure about the memory. I think it doesn't use actual CPU memory. But yeah. Yeah, so whenever you stop using your container, make sure to remove it. Okay? All right, then yeah, also just so that you know, you can get help for specific commands, yeah? So this docker help is massive because you have all the options, okay? But if you want to get help about a specific command, you can, for instance, about the run command. Docker run, what options do I have? So you can use docker run help, see? And now you're going to see here all the options for the docker run specific command, yeah? Or docker rm help, for instance. And here you get specific options for the docker rm command. Or docker ps, yeah, to get all the different options for this specific docker command. Okay. Now, okay, so we have we have pulled different Docker images. We have run some of these images on in containers, in Docker containers. But where do these images that we have pulled come from? They come from the what is known as the Docker Hub. Okay, you have the link right here in section 1.5. You can click, and this is going to take you to the Docker Hub. Okay, so this is the place where all the public images are available. Yeah, then you can create your account, log in, etc. And here at the top, you're going to see this search bar. For instance, if you type ROS here, you are going to see all the Docker images related to ROS, or which contain the ROS keyword at least. As you can see, there are 16,000. Okay, and in particular, the first one that you have here is the Docker official image, and this is the one that we have been downloading here in our during the open class. Okay, you have others. Anyways, you are going to find many from. So this one is from the is the official one, yeah. But you are going to find other ROS images from individual developers, etc. Okay, and the same for anything. So if you click here Ubuntu, you are going to find all the images related to Ubuntu or Gazebo, let's say, yeah, or NVIDIA, for instance. Okay, so you are going to find all the public images here in the Docker Hub. And if you get inside the ROS, yeah, so this is the repository, let's say, this is the general repository. If you click here, you are going to see an overview. Okay, you can get information about this specific repository and how the images, how the Docker images work, how to create your own Docker file, etc. Yeah, so this is the documentation, and here you can check also the different tags. Yeah, so you're going to see all the different tags for each specific Docker image. Okay, and each image contains one configuration. Yeah, OSRF. If I am using a CUDA application in the Docker. If I am using a CUDA application in the Docker, would it still not require CPU or GPU? Yes, it's going to require, if it's using CUDA, I think it's going to require GPU, yeah. But GPU is already available in the CUDA images, if I'm not wrong. Okay, so you have here. Yeah, so here you have NVIDIA CUDA, and in fact, this is a good question because many ROS images created by developers are based on an NVIDIA CUDA image. Okay, but this is something that it's treated in the course. In fact, it's treated in this last unit. Okay, you're going to see some examples of this here. I have to leave. Thank you for your explanations. I like to ask questions before leaving. What is the overhead of Docker, especially when used on embedded hardware like Raspberry Pi or Jetson? I'm actually not sure, Eric. Yeah. So here we have in the chat Ruben, which is our expert in Docker. So it's good that we have him here because he knows much more than me about Docker. And Ruben has answered it, and he says, the heaviness of Docker depends on the containers that you are running. Okay. Also, Dave was asking, does CUDA need to be installed on the host as well, or only inside the Docker? I think that only inside the Docker, but I'm not sure. Maybe Ruben knows better, but I think that CUDA needs only to be installed in the Docker. Okay, so I'm wrong. He says CUDA has to be installed in the host as well. Okay, so there you go with Ruben's answer. Okay, sadly, yeah. All right, and yeah, so we have been seeing different examples, and here we have some of the Docker advantages, which are, as we have already seen in these examples, the isolation, yeah, the replication, also security and open source. Yeah, so it's very, it has many advantages, as you can see. Yeah, we have explored some of them in this hour during the open class. We don't have much time here, but yeah, you have basically seen especially the isolation and replication, yeah, which are two huge advantages. Then let's finish here with a practical demonstration to put in practice a little bit all the different things that we have done. So we are going to start here by running a ROS core. Yeah, we are going to run a container with a ROS core. Okay, this is the Docker image that we have pulled at the beginning, the Robotics ROS core. Yeah, so in the previous examples we were accessing, if you remember, the bash. So here we are going to directly execute a ROS core command. Okay, so let me run this. This is just to demonstrate a scenario. So we are going to start here a ROS core. Yeah, and then in shell number 2 we are going to actually access the bash. Okay, which is the same that we have been doing. Also note, well, we are going to see it in a moment. Yeah. So here I am running a ROS core in shell number 1, and here, if I run a ROS topic list command, for instance, sorry, I am in ROS 1, so it's ROS topic list, no ROS2 topic list. So I get this error, unable to communicate with master message. Okay? So what, does somebody know what is happening here? Why I cannot see the topics from my container here in my second container? This is something that we have already seen. It's the same problem that we were having before, right? Two separate containers, exactly. So we are in two separate containers which are isolated between them, right? So if we come here to a third shell, let me open here a third shell actually, and I'm going to add the Docker group here in my third shell, and here if I run a Docker PS, I'm going to see the two of them. By the way, also, so here if you paid attention, you can see that here we are not specifying the name. Yeah, as in the previous examples, we were specifying the name when we were running our Docker containers. Yeah, let me find an example here. For instance, here. Yeah, so here we are specifying the name of the container. So what happens if we don't specify the name of the container specifically here in the command? Well, that a random name is assigned. Yeah. So for instance, here my first container has been named to Infallible Chandra Sekar, and the second one to Silly Booth. Okay. But here I have the two containers which are completely isolated. I can see here some messages. That Ruben is answering. Yes, but whatever the container is, if you're in the same ROS environment within or outside the container, there is somewhere an overhead due to Docker itself, right? That is right. Docker introduces some overhead. Okay. And the question is, how much is the overhead? Okay. I don't know. I don't know if Ruben knows about how much is this overhead. Yeah, so Fatme was right. Yeah, so two separate containers which are isolated between them. So even though I am running a ROS core here in my first container, from my second one I cannot see it. Okay, I cannot see it unless I do something. Yeah, exactly. So here Dave is saying, but you link them with the net host, so it should add like one machine network. Yeah. So this is what we are going to do right now. Yeah. So here we are just running the containers, right? We are not doing anything else. Then let me get out of the container, right? So down here in the final demonstration, here we are doing something. Yeah. So after we get this error, we add this option, net host. And what are we doing here with this specific parameter? We are doing this, exactly what Dave is saying. Yeah, so we are telling the containers to use the same network as the host. Yeah, as the host machine. So here, let me run again the command with this net host option. So now this container is going to use the host network. Sorry, let me run it here in shell 1 so that I keep. Okay, and now if I run again, if I get the bash here in my shell number 2, also sharing the same network as the host, now if I run a ROS topic list, I can see the topics. Okay, why? Because I am sharing the same network. Okay, I can see many messages here being published. Yeah, yeah. So here we have done what Dave was commenting. Yeah, I can see that there is not a definitive answer, but there are some discussions. Runtime performance cost of Docker containers. Thank you. It's important on small embedded hardware. Yeah, for sure, it's important. Never mind, Eric. Does that mean that we can access? Yes, exactly. Yes. That does mean that you can access internet in your container. Yeah. Yeah. So we can try pinging. I don't know if there is. I don't know. 888 was Google or something like that, wasn't it? Or oh yeah, we don't have the ping command installed in this specific container. So if you want to ping, you are going to have to install ping in the container. Yeah, which you can do, by the way. Okay. Then yeah, so we have seen this small particularity. Yeah, in ROS. So if you want to, for instance, run a publisher in one container and a subscriber in the other one, you have to keep this in mind. Okay. And also the final example in ROS2. Yeah, so in ROS2 it's easier because we don't have this centralized ROS core node. Yeah, so it doesn't really matter, and you can do it directly without having to share the same network. Okay, for instance, a very quick example. Again, we are going to run here an interactive terminal. In this case, in ROS2, okay, in the Foxy image that we downloaded, yeah, and here we are going to run a ROS2 topic pub command, okay, directly. We are going to start publishing here into a test topic, okay. Now in shell number 2, I'm going to access another container, and here I can directly run ROS2 topic list, and I'm going to directly see the topics. Yeah, so I can see here the test topic, and in fact I can subscribe here to this test topic, ROS2 topic echo test, and I'm going to be able to see the messages that are being published here in the first container. All right. So yeah, let me stop and exit this container, and now finally here we can see. In Docker PS, we don't have any container, but in Docker PSA, we have many of them. See, already? All of them with different random names, by the same. So, to make sure that I remove them, I'm going to use the docker rm command, and I'm going to remove all of them. So, sorry. It's docker rm, boring, sweet, Black, Friendly Einstein. I like this name, Friendly Einstein. Elastic, Proskuryakov, Loving Faraday, Infallible, Chance Tracker and Silly Booth. There we go. So I have removed all of them. And yeah, basically that's it. So remember, we have done a very brief introduction here to Docker and some of its more basic commands. We have seen how to download, how to pull Docker images, how to run them, and yeah, how to work a little bit with them. Okay, but in case that you want to learn much more, just let me remind you that we have just published the Docker Basics for Robotics course. Yeah, so here we are going to find much more detailed information about Docker, about, for instance, how to create your own Docker images, how to use Docker Compose to run multiple containers at the same time, and some other very interesting stuff. Okay, then let me have a look here at the last comments. Amna Maizen is showing this error. Yeah, so if you are getting this error, Amna, you need to run this command here in the shell. You need to run this command, these two commands, okay? In order to get rid of the this permission error. Try running the other commands with sudo. Yeah, so of course this is because you are not using sudo. If you use sudo, it's going to work. But if you want to run them without sudo, then you have to execute these commands here. In ROS2, it might not work if no ROS domain ID has been specified. I had this issue once. That's interesting. That's interesting to point, actually. So maybe ROS domain. So here we don't have it specified in these ones, but yeah. So this in ROS2, this environment variable, sorry, is important for connecting different computers using the same system. So yeah, it's something to take into account. Chelsea is asking, what are the applications for Docker in robotics? Is it used for testing and simulations? Yes, it's used for testing, it's used for simulations. Do people use it on actual robots running a real hardware? I wouldn't say so, but I'm not sure, okay? But for sure, for development, it's the main usage is that you can recreate an environment, let's say with a simulation and with ROS installed, and to reproduce a demo, and you can very easily share this for anyone to reproduce. Okay? And for development also, of course, it can be used. Yeah. So there are some interesting tricks when it comes to developing ROS with Docker that we have not explained it here in this class because there is no time, basically. But yes, it can be definitely used for developing. Thomas has to leave. Okay, don't worry. Ruben is pointing that the robot has Docker. Okay. Mm-hmm. So yeah, basically, I would say, Chelsea, to answer your question, that it can be used for almost anything, yeah. But the general purpose, I would say, that in terms of how to apply or use Docker in the robotics world, is to be able to make your code, yeah, or your application shareable, very easily shareable with anybody and reproducible with anybody, yeah. So you develop a robot, your robot does some things, and then if you want to sell this robot to people and that they can start using it without having to install many things and doing many setup steps, the easiest way to do this is using Docker, yeah? Because you can provide to the end user a Docker, the end user can get into that Docker and very easily start using or interacting with the robot. For instance, if if that makes sense. Yeah? Does this answer your question? Yes, thank you. All right, great. Okay, then yeah. So let me close it here. We are already 20 minutes past the time that we should have ended, but we had some issues here with the shells and everything. So sorry for that. We are going to have a look to make sure that this doesn't happen again. And yeah, just right before closing and before everybody leaves the class, let me very quickly activate here the rate form so that you can evaluate this class if you liked it. If not, even with the issues that we had, it's okay. So you can give us a bad mark for this one. It would be understandable. So yeah, as you can see, you are going to get this form here, so you can rate this open class if you like it more, less, whatever. Yeah, this is very useful for us so that we can get feedback and keep improving every time. And yeah, so this is all. I'm going to leave it already here. Thanks to all of you. Sorry for these errors that we had with the shells at the beginning of the class. We are going to work on them to make sure that it doesn't happen again. And yeah, so thanks to all of you. I hope that you enjoyed it. I hope that you have learned something. This is the goal of these open classes. And I'm going to see you again next Tuesday with the next open class. So I'm waiting all of you there. Bye-bye.